Sorry for the inconvenience. I'll start introduction from the beginning since I didn't start the start button of start. I didn't start the recording. Welcome to all for the fifth 5-day FTP on transport infrastructure asset management. We are in the day 3, session 7, that is on treatment choices, preventive and corrective maintenance treatments for bituminous pavements by Professor A. Veeraraghavan, Indian Institute of Technology, Madras. This program is sponsored by the AICTE under the ATAL scheme and organized by the Department of Civil Engineering, NITK, Surathkal. We have already covered topics related to the asset management and road asset management in the day 1. In the day 2, we have covered the topics related to creating the assets, that is in terms of payment, design, construction, and then assessing the condition of the assets. That is the 2 sessions were focused on assessing the condition of the assets. And today we have the first session which deals with treating the assets with proper maintenance measures. So that's how the first session is. First session of today is on treatment choices. So today we have the speaker, Professor Veeraraghavan. Dr. A. Veeraraghavan is currently professor in the Department of Civil Engineering at IIT Madras. He has 4 decades of experience in teaching, research and industrial consultancy. Professor Veeraraghavan received the Indian Roads Congress Pandit Jawaharlal Nehru Bus Sanitary Award in the year 1994 and IIC medals for the best papers in the years 1991, 1993, 1997, 2004, 2008, 2011 and IIC commendation certificates for his highly commended research papers in the years 1992, 1994, 1998, 2000, 2015. Professor Veeraraghavan is a recipient of the UGC Career Award for Young Teachers and National Award for Promising Engineering College Teacher in India from the Indian Society for Technical Education. He was awarded the Vishwakarma Award under the category Outstanding Academician, Technologist, Scientist, Innovator by the Construction Industry Development Council. He has also received the award for Distinguished Services to the Institute by the IIT Madras Alumni Association. Professor Veeraraghavan has published over 100 research papers in journals and over 150 papers in national and international conference proceedings. He has coordinated over 15 major research projects with a budget of over 12 crore Indian rupees. Currently, he is coordinating, that is networking with 10 academic institutions, 2 major research projects sponsored by NRIDA on performance evaluation of rural roads with cold bituminous mixes and performance evaluation of rural roads with waste plastics and bituminous mixes with a total budget of rupees 291.2 lakhs. He has co-authored 4 books on surveying, highway engineering, highway materials and pavement testing, that is 5th edition, by Messrs. Namechand and Brothers, and pavement design, pavement drainage, theory and practice by CRC Press, Taylor and Francis Group of UK. Professor Veeraraghavan is a fellow of the Indian Institution of Engineers India and fellow of the International Society for Engineering Asset Management. He is a member of the National Panel of Experts to implement value engineering program to promote use of new technologies, materials and equipment in road projects by the Ministry of Road Transport and Highways, Government of India. Member of the Highway Research Board, Flexible Payment, Composite Payment, Road Maintenance and Asset Management and Highway Specification and Standards Committee of the Indian Roads Congress. He is a technical advisor to RASTA, Center for Road Technology, Bangalore. Member Technical Committee of the Karnataka Road Development Corporation. He is also a member for the Standing National Advisory Committee on the use of latest technology and innovative materials in the construction of rural roads under PMGSY, NRIDA, Government of India. He is an independent director of Special Purpose Vehicle Road Agencies of L&T, IDPL. He is also the chairman, Board of Governors for the TechU project, Government Engineering College, Idukki, chairman for the cluster level PG program committee of the Kerala Technological University for Ernakulam Cluster 1, and the chairman, and he is also chairman of several technical committees at IIT Madras. With this brief background, it's my pleasure to welcome Professor Veeraraghavan for this technical session, and he has readily agreed and he has supported me in chalking out this program in a proper sequential manner, and also helped in identifying the resource persons for this program. I wholeheartedly welcome Professor A.V. sir for this program. And now the session will be taken by the Professor AV sir. Over to AV sir.
Thank you.
So now you can share the screen, sir.
Yeah. Are you able to see my screen?
Not it, sir. Not it. You may need to minimize the. Maybe few minutes back you tried, sir. The same way. Yes. Oh. Yeah, we can see, sir. Now
Yeah.
slideshow.
Yeah. Is it okay?
Yes, sir. Yes, sir.
Okay. Can I start?
Yes, sir. Yes, sir.
Okay. Very good morning to all participants. I'm happy that the importance of road asset management is recognized in the country. We have all these years we have been constructing the roads, but we were forgetting about how these road assets should be maintained, preserved, so that it will serve the intended purpose. So the major difference between payment design and the payment maintenance and management is that in payment design, we consider a design life. For example, the design life for a bituminous pavement can be 15 years or 20 years, depending upon the category of the road. And for a concrete pavement, it's about 30 years. So the question arises, what is this design life I am talking about? Design life is one in up to which a pavement is not expected to reach below the fair condition, which means it should not warrant major maintenance or major rehabilitation before the end of the 15-year time. But are our highways performing such that they do not warrant a major rehabilitation for 15 years? No. So even though you design a pavement with the right thickness design details for the anticipated traffic, still, because of several factors like the climate, because of the repeated application of loads, because of wear and tear, the pavement will warrant maintenance. Unfortunately, the pavement maintenance is not considered in pavement design. And we do some laboratory tests, assume that modulus values, and then work out the design thickness. But when you translate this design into a reality, you may or may not get exactly the same materials. You may or may not be able to get the required mix, which gave you the properties in the lab. When you try to construct in the field, there will be a variability in the design, in the construction of the materials. This variability in the construction in terms of materials, in terms of mixes, in terms of thickness, will warrant some maintenance for the payments. So in a nutshell, even though you design a payment for a design life of 15 or 20 years or 30 years, because of several factors, the payment will warrant a maintenance. So what are those treatments that are available? Some treatments are called as preventive. Some treatments are called as corrective. So I will take you over what are those treatments that are available, what are the choices before us, and what are the benefits of choosing the right material, right mix for the payment depending upon the condition of the payment. I am happy that you are now aware of the importance of asset management. You're also aware of the different methods of evaluation of the payment. You might have been told that there are two types of distresses in a payment. Some distresses are functional, some distresses are structural. And the payment condition changes once it is open to traffic, from very good to fair to poor to very poor. So different timings of the design life or the service life of a payment the maintenance treatments are to be changed. So what are those treatments which I am talking about? I will take you over the different choices and the different mixes that are available. We do have very good highways. Earlier, we used to say go to other countries of the world to see with good quality roads. Today, we will be able to see very good quality roads in India. This is the Ahmedabad-Vadodara Expressway, 4-lane. But it looks nice when you see an aerial view. But when you walk on this highway, you'll find cracks. Why? That's again, as I was mentioning, because of variability in the construction, variability in the design, variability in the quality control. So if you walk, you will know it better. But from an aerial bird's eye view, you don't find the distress. I went there only to rectify the distresses on the pavement. Similarly, we do have beautiful highways. Again, this is between Chennai and Bangalore, Krishnagiri, constructed by L&T. We do have beautiful highways like this. Even rural roads, when we talk about, they are very good today. So as you know, a flexible pavement consists of different layers, starting from the embankment, subgrade, subbase, base course, binder course, and the wearing course. So what I'm going to today talk about, I'm not going to talk about the lower layers, embankment, subgrade, subbase, or base course. I'm not going to talk. What I will talk to you today will be only about the blacktop or the bituminous layers. This blacktop or bituminous layer, even though it looks to be one blacktop, this again consists of two different layers. You have a binder course and you have a wearing course. So even though when I say blacktop, both look black. Bottom layer has got a different function. The top layer has got a different function, even though we call it as the blacktop. The function of the bottom layer is that it should be subject to more fatigue. So you should be able to resist the fatigue, So the material should be more flexible. Whereas the top layer that you provide should be stiff enough because the stresses are coming on the top here. So this load stresses gets transmitted to the binder course, to the base course, to the subbase, and to the subgrade eventually. So the function of top layer should be, you should be able to resist the high load, higher tire pressure, so that rutting will not take place. So the top layer should be a rut resisting layer, and the bottom layer should be a fatigue resisting layer. But you will find in pavement materials characterization or in pavement design, they consider the same modulus for both the layers. They consider both materials to be the same. They are considered to be HMA, hot mix asphalt, but the functions are different. As can be seen here, the top layer is a rut resisting layer and the bottom is a fatigue resisting layer. So we consider the bottom radial tensile strain as that criteria to resist the bottom of crack. Thing is that these cracks will be found on the surface like alligator crack, map crack, interconnector cracks. When this strain value exceeds the permissible value, then the crack will propagate from here through this layer to the top. So if you want a pavement to last longer, what material or what mix should I consider for the fatigue resistance is the first question. Second, the top layer should be a rut resisting layer. So what should be the gradation? What should be the mix to be provided as a wearing course? So one is a binder course, other is a wearing course. You remember at this point of time. You can also find some tensile strain developing here. So even because of higher load, higher tire pressure, there will be a tension developing at the top. That causes a top-down crack. Unfortunately, we don't consider top-down cracking in the pavement design process because we feel it is material related. But even though it is material related, I think we should consider the influence of the tensile strains that are developing at the top, resulting in a top-down crack. So let us today talk only about these two different layers, a bottom layer to withstand the fatigue and the top layer to withstand the rutting. So there are two different types of layers within the blacktop. So these are some photographs which I took from the highways, which were seen or visible within 5 to 6 years after opening to traffic. What I mentioned was that when you design a pavement like this, the crack may occur at the end of 10th year, 11th year, 12th year. It takes 2 or 3 years for the crack to propagate and see at the top. At the end of the 15th year, you'll find fatigue cracking on the top of the pavement. But these cracks were found within 5 years, 6 years after opening the road to traffic. So what I mean by the term premature is that you design a pavement for 15 or 20 years, and if it cracks before the end of the design life, I call it as a premature crack. This crack will not be a bottom-up crack. You can ask me a question, how do you know that this is a top-down crack and a bottom-up crack? What you should do is you can take a core. Once you take a core, you'll find the cracks are confined only the top, maybe 10, 15, 20, 30, 40 millimeters, beyond which the cracks are not there. You'll see the crack here, take a core, find the cracks are only here. So why I'm bringing this is that all cracks are not alligator cracks. All cracks are not map cracks. So all cracks are not fatigue cracks. So this may be because of the aging of the bitumen on the top. Maybe because higher load, higher pressure. That means the treatment to a pavement which has developed a bottom-up crack is different from the treatment to a top-down crack. So ideally, once you find the cracks, you can seal the crack, but that will prevent the entry of water. Once the water enters, because of hydrostatic pressure that's coming on the surface, it will strip off the bitumen from the aggregates, and then that results in forming of potholes and other distresses. So this becomes a candidate project for recycling. What I will do is that I will mill the layer up to the depth to which the crack has propagated, maybe 30 millimeter, 40 millimeter, 50 millimeter. I can recycle the material, rejuvenate it, and lay it back. That way, I am making use of the already constructed or used aggregate binder. Some binder would have been aged. Now I have to rejuvenate the bitumen, and then I can lay it back. So with the result, we can conserve the materials. We can ensure that the finished road level remains the same, and the performances can be even be better than virgin aggregates, virgin mixes. So top-down cracking is also one type of crack, but all cracks are not bottom-up fatigue cracks. You'll also find rutting. So you'll find a rutting along a wheel path. There are two types of rutting that occur in a pavement system. One is a bottom-up because of excessive vertical compressive strain on top of the subgrade. That also causes rutting. The rutting can also occur because of poor bituminous mix. You'll find the mix is poor, it has sheared. So this has nothing to do with the vertical compressive strain which I am talking about. In that case, rutting will be like this. Large wavelength rutting indicates it is due to inadequate compaction of the subgrade or poor subgrade soil, or maybe because of inadequate subsurface drainage. So the treatment for this is different from the treatment for this. That's why I'm bringing in both are rutting. You may study rutting in theory, but this rutting is different from this rutting. There can also be extensive bleeding on the surface. So what is to be done? So all these distresses which I'm showing are before the end of the design life. This again may be because of the binder, maybe because of the density and voids in the bituminous mix, maybe because of overloading. Many factors will contribute extensive bleeding on the surface. You will also find shear deformation. This is in a gut section between Krishnagiri and Salem in Tamil Nadu. It's a gut section, climbing lane. You'll find that the aggregates mixes have sheared off. So what is the mix to be used? That is the treatment. What treatment should I do for this is what we will see today. Also, this is the fatigue cracking which I'm talking about because of excessive radial tensile strain at the bottom of the bituminous layer. Fatigue cracking can occur. So in a nutshell, when you look at what all I have seen so far, a pavement which is good or excellent initially will start deteriorating with the passage of time, with the passage of traffic. So the rate of deterioration of the pavement is slow initially for few years. Then it starts deteriorating, and the rate of deterioration of the pavement becomes faster beyond a certain stage. So the treatment that you can consider to maintain the road are first is a preventive maintenance. Then comes minor rehabilitation. Then comes major rehabilitation. Then comes a reconstruction. So when you do a maintenance to your pavement in a good structural condition, you'll find good structural condition, it is called as preventive maintenance. When the pavement condition from good, it becomes fat. Then it needs a minor rehabilitation. Minor in the sense, thickness less than 40 millimeter. Beyond that, when the pavement starts deteriorating, it warrants a major rehabilitation, which means thicker than 40 millimeter. So what material, we'll see that. So understand the concept. When the pavement shows some functional distress, top-down cracking, raveling, bleeding, minor rutting, in that cases, you can do a preventive maintenance. When the distresses become more, you do a minor rehabilitation. Riding quality is poor, you can do a minor rehabilitation. When you find extensive distresses, do a major rehabilitation. At the end of the life, you have to reconstruct the pavement. So when the pavement becomes from excellent to good to fair to poor to very poor and failed. So this is the conventional pavement performance curve, which also shows the choice of maintenance treatment that you can consider. When you talk about the bituminous mixes and bituminous layers, it has to serve different functions. Number one, you should offer a high resistance to deformation. So that's what we are talking about. The top layer which I am providing should be able to withstand, offer a resistance to deformation. It should be a rut resisting layer. So what is a rut resisting layer? We'll see. Secondly, the layer should be able to offer high resistance to fatigue. So this material should be able to withstand high strain values, where a truck may carry 8 ton, 12 ton axle load, 14 ton axle load, 20 ton axle load, 28 ton axle load. So the strain values become more. So heavier and heavier loads, more is the strain and lesser is the life. So it is bituminous layers. One should be able to withstand the deformation. They should be able to withstand the fatigue. And you should also be able to reduce the stresses as you go below. Fourthly, the top layer, when it is exposed to atmosphere, the top layer, top few millimeters of the layer will become aged, become stiff. And when you apply a heavy stress on that, this layer will start developing cracks. That is a top-down crack which I am talking about. So because of environmental factors, the layer will be subjected to degradation and can develop a crack. And most importantly, this layer should not let the water to go, which means this mix should be a dense graded mix. A well-graded material should be provided as much as possible. One exception is a gap graded mix. I'll talk about that. You should also have a good workability, so that you are able to achieve the required density of compaction. The voids initially are about 7 to 8%. That is primary compaction. With the passage of traffic, the layer is subjected to more densification. The voids will reduce from 7 to 6.5 to 6 to 5.5 to 5 to 4.5 to 4 and stop. At any given time, there will be 4% voids in a mix, so that in summer, the bitumen will be able to flow within the voids and will not come to the top. So I showed a case wherein there was extensive bleeding that again indication the workability was poor, the voids are more, are initially, which may result in cracking, or the voids become too less initially. The bitumen cannot flow within the voids, it comes to the top. So that is again an issue related to the compaction of the bituminous mix. More importantly, I think you may be aware that they are constructing an expressway connecting Nagpur and Mumbai with a speed of 150 kilometers per hour. A vehicle traveling at 100 kilometers per hour travels 30 meters per second. Now, that vehicle on that expressway will travel at 45 meters per second. Assume that he has to apply a brake. If the surface is smooth, it will skid. It will not be able to stop. So more importantly, the bituminous mix should also be able to offer a good surface texture or a good surface skid resistance. And lastly, you should be able to predict the performance of this. So in a nutshell, from what you have heard so far, you will understand there is nothing like a one size fit all design, or one mix will not be able to take care of deformation, fatigue, texture and friction resistance, environmental degradation, and all this will not be possible from a single mix. There comes the requirement of a treatment choices among different mixes. So as the pavements start deteriorating, what I do here is a preventive maintenance. Later I do a maintenance and rehabilitation. So this preventive maintenance, there are different types. I'll touch upon what are the different types of preventive maintenance. So initially, for a highway pavement, we do a routine maintenance. Routine maintenance is supposed to be done all through the year. 365 days, it is supposed to be done. Now, they don't do it, that's a different issue. That is supposed to be done routine maintenance, which means it includes crack sealing, filling up of the potholes, shoulder dressing, and drain desilting. So these work are to be done all through the year, which is called the routine maintenance. Even though you do a routine maintenance, because of wear and tear, some potholes may form, some raveling may take place, which means a pavement has to be resurfaced. So that is resurfacing. Remember, routine maintenance and resurfacing will not improve the structural condition of the pavement. So even though you do the resurfacing because of fatigue effects, because of other parameters, the pavement will warrant a minor rehabilitation. Minor in the sense 40 millimeter thick treatment. So which is a minor rehabilitation. Even though you do the minor rehabilitation, because of fatigue effect, because of other factors, the pavement will warrant a major rehabilitation. Major in the sense more than 40 millimeter. So this shows the cost. So one is a preventive maintenance and minor rehabilitation, beyond which it is a reconstruction and major rehabilitation. So what are the treatments choices available to us? The first choice available to us is on the binder that you can choose. In India, we have not gone to the performance grade binder specifications. We are only adopting the viscosity grade binder specifications. We use either viscosity grade 330 or 40, which means 3000 poise or 4000 poise. So we adopt only viscosity grade bitumen. Yesterday, I had a talk with one of my students who is working in the border road organization. So they're constructing the road connecting, leading to the Chinese border. So I was trying to find out what is the grade of bitumen they use. Because higher the grade, you have to heat the bitumen to a higher temperature to get the required viscosity. Number one, for mixing. Secondly, for workability. Third, for compaction. So they use VG10 grade of bitumen. So you should be able to choose the right type of bitumen. Again, as I was mentioning, the top layer should be a rut resisting layer. If so, for highly trafficked highways like national highways, you should go in for a modified bitumen. This modified bitumen can be a polymer modified bitumen, PMB, or it can be a crumb rubber modified bitumen, or CRMB, or it can even be natural rubber modified bitumen. In Kerala, Cochin refineries manufacture this NRMB. I study the performance, but my experience is that of the different types of binders which I have listed here, PMB stands out. They are the best of all that. Crumb rubber is not all that bad, but other binders are not acceptable for highly trafficked highways. For low volume roads, they are okay. So now let us fix the binder. Come to the mixes. I told there are two mixes. The upper one is the surface wearing course, bottom is a binder course. So the bottom wearing binder course can be a bituminous macadam, or it can be a dense bituminous macadam. So we'll see what is the difference between BM and the DBM. The thicknesses are almost same, 50 to 75 or 80 to 100, or 50 to 75 or 75 to 100. The wearing course can be a semi-dense bituminous concrete, or it can be a bituminous concrete wearing course. Thicknesses can be 25, 30, 40, or 50 millimeter. So we need a binder course, we need a wearing course. Not all cases, in majority of the highly trafficked highways. So binder course can be BM and a DBM. Wearing course can be semi-dense SDBC or a BC. So we can have BM and SDBC or BM and a BC. You can have a DBM and SDBC or a DBM and a BC. Again, this materials mixes, you can have either VG30, VG40, PMB, CRMB, or NRMB. So now the possibilities of combinations are more and more and more. In addition, we do have a stone matrix asphalt. It is a gap graded mixture. Aggregate contact is possible. We add cellulose fibers. It's the asphalt mortar rich mix. It will offer a good resistance to number one, rutting, number two, skid resistance. It can form an excellent wearing course for all the expressways. I would say that all expressway, the wearing surface should only be SMA. I have also been trying to educate the Airport Authority of India so that even the runway pavements where skid resistance becomes very, very important, the wearing course can only be SMA, but they have a DAC, different gradation. But there are issues with respect to skid resistance. The last one was at Calicut. Maybe one of the reasons may be because of inadequate skid resistance. So you have to choose the appropriate type of treatment depending upon the function. Supposing if the highway carries a very heavy loads, the binder course is also subject to more fatigue. In such cases, you can go in for an SMA as a binder course, SMA as a wearing course. Why are we not using that? Because it's costly. Preferably, we should use a modified binder. We use cellulose fibers. Minimum bitumen content is 5.8%. It will be at least 50% more than a bituminous concrete. So we try to cut corners, reduce the cost, reduce the choice of mix, and then consider only BC. But considering the functional point of view, the SMA is the future of the bituminous mix for a highly trafficked highways. In addition, when you find top-down cracking, raveling, you can go in for recycling. It's again a corrective maintenance treatment, which can be hot mix, it can be a cold mix. Again, it can be done in situ, or it can be taken to a central plant and you can mix it, bring it back. So these are choices of corrective maintenance treatment that are available to you. So you'll find that DBM, SDBC, and BC are the choices. Again, there are two gradations. The bitumen content will be 4% and 4.5, 4.5 and 5, 5.2 and 5.4. So you'll find that as the aggregate sizes become smaller, surface area becomes more, and the requirement of binder content is also more, 5.4% minimum. Again, you should also understand one more concept of the nominal maximum aggregate size. So this is the largest size where 10% of materials are aggregates retained. So 95 to 100, so 37.5 is the nominal maximum aggregate size. In this case, it is 26.5. In this case, 13.2. So you will find that nominal maximum aggregate size plays an important role on the thickness of the layer. Generally, in a granular layer, there should be two aggregates, one above the other. But in the case of dense bituminous mixes, we require minimum 3 aggregates, one above the other, preferably 4. So if T is the thickness of a given layer, the maximum size of aggregate can be T by 3, preferably T by 4. So once you reduce the aggregate sizes, surface area becomes more, binder contents become more. So what is the issue here? So when you have 35 millimeter thick layer with a nominal maximum aggregate size of 37.5, only 2 aggregates can be there, one above the other. The mix cannot be dense mix. Therefore, you will find segregation problem in the case of DBM grade 1. So the treatment choice for you if for a binder course is DBM grade 2. Again, should I use a modified binder? Generally not required, because the temperature coming at the lower level of the DBM is not that high there you can go in for conventional with unmodified bitumen. SDBC we recommend for very low traffic highways, but the Ministry of Road Transport Highways has deleted this from the specifications because of not satisfactory performance. For low volume roads, still we can go in for SDBC because this is better than the conventional mixes. We can also go in for bituminous concrete. BC is the preferred type of wearing course. But remember, once you provide BC as a wearing course, all subsequent layers should only be BC. Again, when you have 50 millimeter, 19 is the maximum aggregate size, nominal maximum aggregate size. But I have got a concern here. When you say 25 millimeter or 30 millimeter in the Ministry of Road Transport Highways, I have 13.2 millimeter aggregates. Assuming the 25 millimeter is the layer thickness or 13 millimeter, 30 millimeter. When you have 13.2, only 2 aggregates can be there. Therefore, there is a need to bring in another gradation with 100% passing through 9.5, which can be used for 30 millimeter. So treatment choice can be 50 millimeter for heavily trafficked national highways, 40 millimeter for medium level traffic, and this 30 millimeter can be used for urban roads as well as for low volume roads. So binder can be different, mixes can be different. In the case of bituminous concrete as a wearing coat, you should go in for a polymer modified bitumen or a crumb rubber modified bitumen. So these are the 3 choices that we have here. BM is carried out in a hot mix plant, compacted mechanically, but unfortunately there is no mix design. The check is only on gradation, check only on the binder content. So binder content is low, 3.3 to 3.4. So people prefer this, but the voids are more. So imagine a case of bituminous mix with more voids. You take a glass of water and pour on this, entire water will get in. That is not a good mix. So you will not get a dense mix if you provide a bituminous macadam. You'll find that the voids may be of the order of more than 10%. This is grading 1. Even when you take grading 2, the voids become more. Therefore, even if you consider load carrying capacity, assume that I apply a load and measure the strain here. When you compare the load distribution within this, because of too much of voids, they are not effective. So if you look at the equivalency, then you'll find that instead of providing 150 millimeter of a waterborne macadam or a granular layer, you may have to provide 10 centimeter of a bituminous macadam. It's not cost effective. The cost of this will be more than 5,000 to 6,000 rupees per cubic meter. So therefore, why Indian roads are bad is because we adopt this open graded or a high void mixes. So what is to be done? We have to go in for a dense bituminous layers. So DBM layers consist of coarse aggregate, fine aggregate, filler. There's a mixed design. Binder content is fixed. Minimum values are prescribed. There is a volumetric analysis. There's a test on the moisture susceptibility. With the result, instead of a BM, you can go in for a dense bituminous macadam. It's usually used as a base course or the binder course. And whenever you want to provide a profile corrective course, for example, I have a 2-lane highway. It has got 2 camber on both the sides. Now I want to convert this 2-lane into a 4-lane, which means I'm making this into unique camber. In that case, there will be a wedge. What material will you use to fill the wedge? If you ask an engineer, he'll say, I will use BM. But the BM that you're going to provide will be like this. All the water that gets in through the near the median will get accumulated here, and that causes premature cracks on the surface. Therefore, the profile corrective coat should only be dense bituminous macadam. It can be constructed in single layers or multiple layers. Thicknesses vary from 50 millimeter to 100 millimeter. Again, it is a closely graded. Use the binder coats for heavily trafficked highways. We use cement or a lime. Out of these two, the added value of cement is very, very less. It's not that mandatorily you should use cement. But if the aggregate has got a water absorption slightly higher, to prevent stripping, you can add hydrated lime. If we add minimum 2% lime, the function or the performance of the bituminous mix will be much, much better. So hydrated lime can be used if the mix fails to meet the water sensitivity requirements. So it's what I was told about telling about the DBM grade 1. Again, lot of segregation can occur. Take a glass of water and pour, the water will get into this DBM layer. Therefore, out of this, whenever you try to find a premature failure, you take a core from that, take a cut, make a trial pit, and then you'll find that there is no bitumen on the aggregates where they have gone. This again indication of too much of segregation. Water gets in because of pervious mix in the top layer, and you'll find that aggregates look like granular layer. Extensive stripping will take place. Therefore, to make life simple, you can consider DBM grade 2 to be the preferred binder course for highly trafficked highways. Again, the in-place voids, to what voids I should compact. So if you have got 25 millimeter, 90 millimeter aggregate, the void is 8%, you'll find that permeability is of the order of 1200 plus. So gradation, nominal maximum aggregate size, and the in-place voids plays an important role on the permeability of the mix. Therefore, DBM grade 2 can be considered to be the treatment choice for the binder course. When it comes as a wearing course, we can go in for a bituminous concrete, which is again a dense graded bituminous concrete, a wearing course for heavily trafficked roads. The quality control involves the mix design to be done. Gradation is there. And as I was mentioning earlier, you have fixed gradation for the BC, binder content 5.2 or 5.4. We can do the mix design in the laboratory, check the optimal binder content corresponding to 4% voids. We can check the mixing laying compaction temperature. We can check the density, stability, flow, voids, retain stability, binder content, gradation. Therefore, it is possible to ensure a better quality construction if you adopt such dense graded mixes like bituminous concrete. Grading quality is also important here. Even though ministry has deleted the semi-dense bituminous concrete up to 10 MSA, we feel that we can still adopt semi-dense bituminous concrete. The Indian Roads Congress specifications are still available for SBBC. So I also feel that for a low volume roads like rural roads, where the traffic is order of 5 million standard axles, 2 million standard axles during the design life, SDBC can be laid directly over a wet mix macadam as the wearing course of thickness 25, 30 or 40 millimeter, and this will be much better than open graded mixes. So there are requirements of the volumetrics as well as the requirements of the mix. So the minimum value of stability is 9 kilonewton, and we use a modified binder, it should be 12 or 10. Flow values, quotient, Marshall quotient, air voids 3 to 5, approximately 4 is the average that we consider. Similarly, voids in the mix also plays an important role. So you should do a mix design, select the appropriate gradation, find out the optimal binder content, check the flow, check the voids, and ensure that VFB and VMA also follow the required specifications. If too high a VMA also causes problem, it may meet other requirement, but it may not meet the VMA and the VFB requirements. They also are important for ensuring satisfactory performance of the pavement. So when I say that this such shear deformation taking place in a BC, understand BC will not be able to withstand higher shear resistance. Therefore, we need a different mix to prevent this. Rutting and shoving is also from the same section which I'm talking because of the poor bituminous concrete mix. In some cases, if you adopt DBM as the binder course, you can find the top bearing course looks intact, but you'll find the binder course has sheared off. Because of aggregate shapes, you find that they are more rounded, they are not angular. So aggregate shape also plays an important role. If your binder course has too much of voids, it can again shear off. It need not be contributed only to the wearing course. Any mix that you construct, if you got too much of voids, it will eventually crack. Too less of void, it may not crack, but it will flow, it will bleed. So now you have to strike a balance between cracking and bleeding. You'll find that whenever the mixers had too less a void, it resulted in rutting. Too high a void, there's no rutting, but water can get in and may result in cracking. Therefore, a hot bituminous mix should be compacted to approximately 7 to 8% voids initially. That is what I mean is 93% of the theoretical maximum density with around 7% voids initially. So these voids will decrease and you should never go below 4% during the design life of 15 years or 20 years. Compaction plays an important role. So if you find that the voids are around 5%, 6%, then the fatigue life is also more. So don't have too much of voids, that will decrease the fatigue life of the mixers. Therefore, the solution that we should consider for a wearing course and a binder course is a stone matrix asphalt. So this stone matrix asphalt is a gap graded mix, a rut resisting mix. It consists of high quality aggregates. It has got an asphalt rich mortar, mineral fillers, as well as cellulose fibers. When you use this mix consisting of asphalt rich mortar and cellulose fibers, it's a forms and coarse aggregate skeleton and an asphalt binder rich mortar. So there's an aggregate to aggregate contact, stone to stone contact. With the result, performance will be a rut resistant mix. That's how an SMA will look like. So you'll find a rust resisting mix, very high skid resistance, reduced water spray, noise reduction is also possible, and a durable mix. Even in the case of airfield runway pavements, the taxiways where the aircraft crawls at a very low speed and it waits for clearance to take off. So you'll find that when the aircraft leaves the airport to take off, when the fuel tank is full and the load is more, the aircraft crawls along the taxiway and waits for the takeoff. You'll find rutting all along that taxiway. When the aircraft lands, the fuel is already burnt, the load is less. And the exit taxiway will not be subjected to a very heavy load application like the taxiway that is leading to the runway. In such cases, the preferred mix treatment is a SMA. Composition, again two gradations, one passing through 13 and passing through 19. This can be used as a binder course for heavily traffic roads. There are highways which carry more than 30,000 trucks per day, heavily loaded, going for SMA binder course. If you have the traffic is less, but still you want a rut resisting mix like the Nagpur Mumbai expressway, where the speed is 150 kilometers per hour, go in for SMA of 13 millimeter with a nominal max aggregate size of 13 millimeter. So this is how you have to choose the appropriate treatment. The requirements, air voids is 4%, minimum binder content is 5.8%, rain down should be 0.3 maximum percent, and the tensile strength ratio should be 85 minimum. So this is again the requirements. The mix design has to be carried out. So if there is no fiber, all the binder will flow because fines are less. But once you add the fiber, the binder flowing out will be very, very less. Therefore, there is a need to add a cellulose fibers to this. That's how an SMA mix will look like. So to make life simple, binder course is a SMA grade 2. Surface course can be bituminous concrete, maybe 40 millimeter or 50 millimeter or 30 millimeter. Or you can go in for SMA grade 1 or grade 2 as a binder course or a wearing course. These are the choices available to you for a long lasting pavement. This is how your surface will look like after the rut test. Now, let us come to thin bituminous surfacings choices. We conventionally use this PMC. It's also called as open graded premix carpet, OGPC. When the term itself says it is open graded, then you can ask me, you just now told you should adopt a dense graded, but you're also now telling upon open graded premix carpet. Yes, why Indian roads are bad is because we adopt such open graded premix layers. It is a single size gradation, maybe 13.2 and 11.2. When the country is 14.6. So if you take a glass of water and pour on this, the water will get into that. That causes stripping. So what I do is that I provide this premix carpet, which is open graded, and cover it with a seal coat. This seal coat can be of two types, liquid seal coat and a premix seal coat. In a liquid seal coat, what I do is that I apply a layer of binder and spread the aggregates on the top. This layer of binder which I apply will serve as a waterproof layer on which aggregates can be spread on the top. For example, you are constructing a road in Mangalore or even in Kerala or in Maharashtra in the coastal region. Rainfall is heavy. Go in for a liquid seal coat. Don't go in for PMC. If you go for a PMC, go for a liquid seal coat. In other dry regions, you can have a premix seal coat, which is also called as a type B seal coat. But remember, premix carpet warrants a seal coat. Both put together is around 20 millimeter. This is how an open graded premix carpet can be laid, but you will find that all distresses will occur because water will get into this and causes premature failure. No sand seal coat. This is called as a grease ring test. You have a ring of grease, pour a glass of water in that, and find out how long it takes for the water to enter. No sand seal coat, water will percolate in 5 seconds. On this layer, if you have got a moderate sand seal, still water will get in about 30 seconds. If you have a heavy sand seal, the water will percolate in 9 minutes. Eventually, water will percolate. But if you provide a bituminous concrete surface, for hours, water will not get in. So water is enemy number 1, enemy number 2, enemy number 3. So if you do not want water to get into the lower layers, adopt a mix for which there is a mix design. Quality control is possible and is impermeable. BC mix will fulfill all the requirements. We can also go in for a closely graded premix. I told open graded premix consists of two different mixes. One have open graded mix and a seal coat. Now you can consider both the mixes and then consider as one mix in one operation you can lay. When compared to the open graded premix, this closely graded premix can perform better, relatively better, but still it's an alternative to the open graded premix. It may be constructed using a paver. With the result, surface finish is good. There are two types, type A and type B. For 20 to 25 millimeter, you can lay this closely graded premix surface, even though it is not a preferred wearing course. But what I found is that when you have laid a wet mix macadam using a paver, I have no issues in providing mixile surfacing with a paver. But when you have laid with a waterborne macadam, surface is uneven. And if you provide using a paver, a premix mixile surfacing, at the edges you'll find the thicknesses are very less. Due to wear and tear, they get worn out. You'll find more here. Therefore, I do not recommend adopting mixed seal surfacing or MSS directly over a waterborne macadam. One thin bituminous layer is required before the mixile surfacing is laid. But both I would not recommend as the preferred choices of thin treatments. So that as the pavement conditions start deteriorating, the pavement needs some more preventive maintenance here. And if I spend here, it costs 1 rupee. If I delay it more, it costs 4 to 5 rupees. So more and more you delay, more and more will be the maintenance cost. A stitch in time will save 9. So what are the choices here? For pavements which start deteriorating like this, if I do a treatment later, it is called as a reactive maintenance or a corrective maintenance. It is something like taking antibiotics. On the other hand, if you do the maintenance earlier, it is called as a preventive maintenance. It is like taking vitamin tablets. You'll find the health of the road network is much better. Pavement condition, we call the term health. The health here is much better. Very good. Here, health is poor. You are in ICU, but you are consulting a doctor here. So what are the choices of preventive maintenance and corrective maintenance? We saw reactive or corrective maintenance. Let us see, in a case of preventive maintenance, if you do the maintenance here much lower, cheaper in cost, 1 rupee or less than a rupee. If you delay it more, the cost will be 4 to 5 rupees. So by doing the preventive maintenance here, you'll find that the life extends by 2 years. From 10 years, it will reach the fair condition. But because I am doing a preventive maintenance here, I am ensuring or ensuring that the pavement performs better. I am ensuring that water will not get to the cracks. I will ensure that the surface does not get aged, so that I do a treatment here because the water is not able to enter into the lower layers. The life extends by 2 years. So simple cost-effective treatment can extend the life by 2 years. What are the choices? This can be a fox seal, a slurry seal, a microsurfacing, a surface dressing. Again, a single coat or a two coat. Thin overlays, thickness less than 40 millimeter. Again, semi-dense bituminous concrete or bituminous concrete. Again, the same binders, you can use any of this. So all these treatments which I'm talking about, a fox seal is a light application of diluted slow setting emulsion. What it does is that when the surface is hungry, raveled, it will seal the layers. It will prevent raveling. It will enrich oxidized asphalt layers. It provides a delineation with the shoulders, but it will work only for a pavement in a good structural condition. Not for undulated pavement, don't apply a fox seal, number one. But more importantly, don't ever apply a fox seal on an expressway, on a national highway, on a runway, because the skid resistance will drastically reduce. Only for low volume roads and low speed highways, if you want to rejuvenate, you can go in for a fox seal. It's a light application of low viscosity emulsion for sealing the cracks. It's a slow setting emulsion we use. You spray the binder at the rate of 0.5 to 1 liter per square meter, and traffic you can be allowed after 24 hours. As you know, emulsion is bitumen granules in water. Once the water evaporates, the bitumen settles on the surface. Slurry seal is yet another type of mix, well-graded fine aggregate with a mineral filler. Again, a slow setting emulsion. Thickness varies from 3 to 12 millimeter. It can also be applied to prevent raveling, improve the friction, and to reduce the stripping. So in this case of slurry seal, mix of fine aggregate, Portland cement, and lime method filler. Emulsion is used, slow setting emulsion and water. Thickness is only 5 millimeter. So when the pavement is in good structural condition, and if you started showing raveling, minor cracks, minor distresses, you can apply a slurry seal. It will also seal the cracks and fill the minor depressions. After applying a tack coat, you can lay a slurry seal. Thickness varies 5, 3, 1.5, and the quantity of binder and the coverage also varies. So this is a known equipment. It got the fines, it has got the filler, it has got the emulsion. All these are mixed here itself and laid on the surface. So slurry seal can be adopted for a pavement in a good structural condition but showing surface distresses. Remember, all these layers will not improve the structural condition of the pavement. They'll improve the riding quality, they will seal the cracks, they will ensure that the performance is improved by applying a slurry seal. Microsurfacing I found to be a successful treatment which I can recommend anywhere. Not for high-speed highways, even though they're adopting, but for majority of the highways, we can go in for microsurfacing. It can also be used for bridge decks to improve the riding quality. It's a mixture of polymer modified emulsion, high quality aggregates. Thickness varies from 8 millimeter even up to 20 millimeter, ISO 10 to 20, but even from 8 millimeter up to 20 millimeter. Again, the mix can give you a riding quality similar to that of a hot mix, BC. Cheaper, it may cost around 200 rupees per square meter. It's only emulsion, cold mix, no heating. So even in our IIT Madras, I have suggested to go in for microsurfacing. Perhaps after the monsoon, we'll adopt a microsurfacing for the campus roads. Fill the ruts, seal the pavement. You can open the road to traffic in 1 hour. Module rise in the height, less environmental pollution because of the cold mix, life comparable to that of the hot mix, faster laying process, high durability. That's how it looks like in 1 minute, in 1 hour, in 1 day. So you'll find a perfect smooth riding surface. The life can be easily be 3 to 4 years for majority of the roads. For low volume roads, it can even be higher. So my recommended treatment for a preventive maintenance is microsurfacing. Surface dressing is yet another layer which can be adopted for low volume roads. Again, similar to that of the type A seal coat, which I have just now talked about. Stone chippings protect the film of binder. First apply the binder and then apply the stone chippings. So you can also go in for a pre-coated aggregates, which mean you coat the aggregates with 1 to 2% binder. So the aggregates are already coated, they will bond with the binder layer that you are applying on the surface. Good wearing surface for low volume roads. It protects the waterborne macadam. The binder serves as a waterproof layer. It also prevents the deterioration of the pavement. More importantly, it also offers a high skid resistance. So what I do here is it can be a single coat or a 2-coat surface dressing. You spray the binder, spray the aggregates. Use a pneumatic roller and compact. So here I spray a binder. This binder serves as a waterproof layer. This is an emulsion. You'll find that water vapor evaporates on a hot summer day. So the binder serves as a waterproof layer. On this binder, you spray the stone chippings uniformly. And compact the pneumatic roller. Job done. Cheaper than your premix carpet. Life better than your premix carpet. Then why are you not adopting? Because these chip spreaders are not available in India. On the other hand, you can go in for a single coat surface dressing, or you can go in for a 2-coat surface dressing, depending upon the traffic as well as the other parameters, rainfall conditions. Low rainfall, low traffic, single coat surface dressing. In the case of high rainfall, high traffic, go in for a double coat surface dressing. What I do is that on a given surface, I apply a layer of binder. On this layer of binder, I apply a stone chippings and compact with a pneumatic roller. That is called a single chip seal or single coat surface dressing. On this, I apply the second layer of binder. And then on this binder, I apply the second layer of small aggregates that will key in to the voids in the coarse aggregates and compact the pneumatic roller. This is called as a double chip seal or 2-coat surface dressing. High rainfall, high traffic, double coat, 2-coat. Low rainfall, low traffic, single coat. This will be good. This is adequate. This is how you compact with the pneumatic rollers. These chip spreaders are available from Himakshi in Gujarat. Cost nearly about 2 to 3 lakh rupees, 3 to 3.5 lakh rupees. It can be fitted to any tipper. As the tipper moves, the aggregates can be uniformly spread. So machinery are available. It's only the willingness to use the technology is missing. But if the binder is not properly applied, there can be a failure of the surface dressing. Mastic asphalt is another layer, a mixture of bitumen, filler, and fine aggregates, mainly used as a voidless compact mix. The major problem with the bituminous concrete is the shear deformation. Assume that in the case of GOT roads, assuming in the case of an intersection or a bus stop where the buses apply a brake, so there will be a shear deformation. You'll find the shoving crescent shape movement of the binder mix, maybe because of the tack coat, maybe because of the mix. In such cases, if you want to have a shear resistant mix, you can go in for a mastic asphalt, wherein I heat the mix consisting of fine aggregate, filler, and the bitumen. They are cooked in a mastic cooker to a temperature above 200 degrees centigrade, and then it flows like a liquid on the surface. It is used for heavy duty pavement, city streets, bus stops, junctions, as well as bridge decks. But the mix will not have the required skid resistance that is required. Therefore, the ministry recommends spraying of stone chippings on the surface that you can find in many of the junctions to improve the friction. So for the roads and carriageways, you can go in for 25 to 50 millimeter. For heavily stressed areas, you can go in for 40 to 50 millimeter as the thickness of the mastic asphalt. But the bitumen that you use cannot be the bitumen that you use for road construction. This is an industrial grade bitumen with a penetration 15 plus or minus 5. So 10 to 20 should be the penetration value. So bitumen should be an industrial grade bitumen. There are other requirements which are given here. This is a bridge in Kerala which was constructed. They have constructed with a mastic asphalt and cemented wearing course, but you'll find that full of potholes. The collecting of the toll, people were not willing to pay toll for this pothole filled road. So how should the mastic asphalt be laid? So in some cases, what is to be recommended is that above the concrete pitch deck, there should be a protective layer. This protective layer should be a waterproof layer. Now, if you go to AICTE-ATAL website, you'll find that rolls. They are bitumen impregnated geosynthetics, which are available in rolls. Apply a tack coat, spread this first. That serves as a waterproof layer. On that layer, provide a mastic asphalt as the binder coats. On the top, provide a bituminous concrete as a wearing coat. Again, there's a miscommunication between the ministry specification and what we people have understood. They provide bituminous concrete at the bottom and the mastic at the top. As I was mentioning, mastic will result in skidding. Mastic should be a binder course, a second layer as a waterproof layer on which you provide bituminous concrete as a wearing coat, which can mild relaid back. So in the European specifications, they have a concrete surface. So above the concrete surface, you have a spray, a primer, bitumen sheet. This is what I'm talking about. Then they suggest a bituminous mastic asphalt protection layer and mastic asphalt wearing coats. So there are two mastic asphalt layers. I say one mastic asphalt, one BC, or it can be twice mastic asphalt with stone chippings on the top. But a bitumen sheeting as a waterproof layer is required. This is again the same case, liquid plastic sealing layer, a connection layer, mastic asphalt protection layer, and mastic asphalt wearing coats. In France, they adopt a polyurethane resin, mastic asphalt, and a bituminous concrete wearing surface. But we have to change our specifications in the Indian context for a long-lasting wearing coat on the bridges. Porous asphalt is another layer. I personally feel that open grader friction courses should be adopted. These porous asphalt ensure the water drain off from the surface. We are able to see the road visible ahead, offers a good skid resistance on the surface of the pavement. So you'll find that when you have a dense mix, there will be a splash of water. But here you'll find that water has got into the layers. So that will ensure that the surface will offer a good skid resistance on the surface. The road markings are visible, so it is time that we go in for a porous asphalt. So here there will be also a reduction in the noise possible. So this is the preferred wearing course for a heavily trafficked as well as high traffic, high speed highways like the Nagpur Mumbai expressway or any expressway for that matter. You should go in for this open grader friction course. But clogging will be an issue. But you have to remove the water. Even in case of airfield runway pavements, I would suggest that the top layer can be this open graded friction course, wherein all the water will get in, surface will look dry, and will offer you the required skid resistance. So for all roads, before you do the bituminous layer, the surface has to be prepared. You have to remove and replace the failed areas. You have to patch all potholes, seal all the cracks, fill all the ruts. To ensure that the profile corrective course is used using a dense graded mix, and you can have to clean this with a mechanical broom. So this is what I was talking about, the wedge. This wedge should not be with the open graded mix like a BM. This wedge should be a dense graded mix. Otherwise, when you convert a dual camber into a single camber, all the water will get accumulated here. You'll find cracks on the surface. So surface preparation plays a very important role. And the corrective course, this is the correct method of doing the profile corrective course, not like this. This is the incorrect method. Layer by layer, you should compact before you come to the top. And when you find that surface has extensively cracked, fatigue crack, because of a delay, what is to be done? When they provide a thin SDBC, thin BC on the surface, the same crack will get reflected on the top. So what is the treatment here? So if you want the life of the pavement to be extended, you provide a geofabric with a geogrid. Or you can have a geogrid also. But it requires a thick bituminous layer of thickness minimum 75 millimeter. So this geogrid layer will take care of the relative movement and then ensure that the crack does not propagate to the top. So this is called the reflection cracking. To retard the reflection cracking, you should provide a geofabric with a geogrid with a thick bituminous overlay. So that even though you design and construct the pavement as per specifications, the pavement prematurely fails. Why? So it's a case of a highway which prematurely failed in 3 months. They spent 2,400 crores to construct the road, but the road failed in 3 months because of many factors. I could take the road was opened, completed, the construction was completed sometime during April, May. I went in September. Only June, July, August, 3 months, I could find potholes. So you find that BC 40, DBM 120, Bituminous Pavements 250, GSB 200 and 500. But the road which is looking nice like this has become like this. So what I mean to say, before I conclude, what I mean to say is that quality becomes a very important role. It's not the mix, it's not the choice of the mix. Unless you ensure a good quality, the pavement will prematurely crack like this, potholes will form, and 3 months' time, the pavement has failed. So 130 kilometers of the 240 kilometers failed. I suggested a treatment of milling and overlay in 2015. For 130 kilometers, it cost 130 crores. They did not do it because they thought that my suggested treatment is costly. They delayed and delayed and delayed, and now they are doing it, but the cost now has gone up to more than 400 crores for the repair only. So quality of construction plays an important role. So you'll find stripping on the surface. So what we found is that you name any type of distress we could see: open graded texture, loss of aggregates, hungry surface, alligator cracks, shoving, wheel path depression, all types of distresses we could see in one road because of combination of several factors. So when you try to study what went wrong, you'll find that this is the case of DBM, this is the case of BC. What we found is that in many cases, the DBM layer was poorly compacted. We also find that air voids are more. But we find the binder content was fairly okay. But in the case of bituminous concrete, the binder content was very low. The voids were high. Compaction was poor. So in a nutshell, if you want a pavement to last longer, you should choose the right type of bituminous treatment, right mix, laboratory mix design and the field mix design all should tally. And if the binder content is low or compaction is poor or air voids are high, the pavement will prematurely fail. So what we found is that when the pavement is compacted to very high density and the plasticity index of the GSB was lower and the density of the bituminous layers are high, no distress. When they were poorly constructed or the plasticity index became more, you will find distress. So quality control of all the layers plays an important role on the performance of the pavement. So theoretically, you can design a mix. Theoretically, you can predict the performance in an asset management system. But what I want to emphasize at this point of time is that construction quality should also be factored in the performance prediction models. Theoretically, it may last for 15 years. Theoretically, the overlay may last for 10 years. But if the mix is poor or the lower layers are not properly constructed, the life can come down from 10 years to 4 years or 3 years or even 3 months. So your prediction model plays a very important role in a road asset management. Considering quality should also be factored. So I thank the Ministry of Road Transport, Highways and the Indian Roads Congress for the information literature which I got. So to summarize that, there are different choices of bituminous mixes. One is a corrective maintenance, other is a preventive maintenance. Among these, again, there are different choices. The choice of the treatment and the constraint quality plays a very important role on the performance of the pavement. So with that, I conclude. So if you have any questions, I'll be very happy to clarify your doubts or any clarification that you need. It's open now for discussion. I think I have not gone beyond time. It's only just within my time I have completed.
Thank you, sir. Few of the participants have raised their hands during your presentation. Probably they have some doubts.
They can raise the hand. They can unmute and then ask.
Yes.
Namaskaram, sir. This is Vishnu from NIT Warangal.
Yeah, tell me. Go ahead.
Yeah, sir. You actually presented a graph showing air voids versus rut.
Yeah.
Are those the air voids of mixes which were cored after they showed rutting.
Yeah. Yes.
So that is not in place air voids.
Correct.
That is
But
not in place.
what I mean to say is that if the assuming that many people what they do is that they compact to 4% voids initially. Because the mixed design is done for 4%. When they do at 4%, when it reaches 2%, it starts bleeding. That's what I wanted to show. It ruts. That's what I wanted to show from the graph.
Okay, sir. Suppose if our mix aggregate skeleton is good enough that it resists compaction,
yeah,
then it would be advantageous for us to compact it to lower air voids itself initially.
But whatever you try to do, whatever you try to do with a conventional method of compaction with the steel tires, the pneumatic tires compact much better and ensure a better compaction. So even though theoretically you get here maybe 5%, assume that you have a 5% void. This is again another question that is debatable. I can take your question in another way. What I mean in another way, what I mean here is that should all payments should be compacted to 96% or 98%? When will they reach 4% voids? This question I again asked with the airfield payment also. So airfield payment, the wheel path is fixed. More or less is fixed. Maybe within 3 meters on either side of the center line, that is the wheel path. The runway payment is 45 meters. Beyond this 6 meter in the central, those areas are less trafficked. So if I have 8% voids in those areas, water will get in. They will develop cracks. They will ensure rainfall. Similarly, if we consider a state highway, national highway, and the MDR, assume that all of them are compacted to 8% voids initially. At the end of the 15th year, if you find the MDR or ODR would not have reached 4% voids. With the result, there will be a cracking on the surface. Therefore, this initial air void should be linked to the traffic. That is the area for the study.
Sir, okay.
Yeah.
Sir, my second question is, say when you're actually suggesting SMA as a wearing course, what would be the binder course there? Because when you go for SMA would be pervious also. So if water gets into the SMA, it can actually come into a bottom DBM, which only has got 4.5% binder.
Yeah, but that is very less because it is an asphalt-rich mortar. The probability, I think somebody can do a study on the permeability of the SMA mix. I have not done it. Maybe that you can try to find out is it permeable. I am not sure. I don't know. As far as I know, yeah, you go ahead.
We'll work on, sir. We'll work on.
Yeah,
so the third question is when you're actually suggesting micro surfacing, or when you're actually suggesting surface dressing, you were suggesting pneumatic rollers to be used.
Yeah.
Can we use a static roller for a 6-ton capacity?
See, the issue is that some amount of kneading is also required. That is why the pneumatic roller is preferred on that. They should get into the binder that you have sprayed on the surface. It will try to fix. Steel tire will try to fix. But this pneumatic roller will try to ensure that the binder works up on the top. The aggregate should be held by the binder. The pneumatic roller will ensure the binder to work up to the top, whereas the steel tire roller will not ensure that binder coats the surface of the aggregate to the top. That is why it is preferred to go in for a pneumatic roller.
So majority of the PMGSY contractors may not have pneumatic rollers with them.
I think in India is everything available. Only thing is that it's a question of chicken and hen. If you introduce it in the contract condition, they will bring it. I think we have to make a start. I am trying my level best, but I have not been successful in this because it is cheaper.
Yeah.
That is the issue. They want more money. They want for every PMJC road 50 lakh rupees per kilometer or more. This will reduce the cost that they don't want.
Sir. Thank you so much, sir. It's always a blessing to hear from you, sir.
Thank you. Anybody else? Anyone has got any other question?
Sir, good morning, sir. This is Ashish Wali from IIT Roorkee.
Yeah, tell me.
Thank you, sir, for this insightful presentation. I need a clarification. You have shown a graph of rate of deterioration with time.
Yeah, right.
On that, there is some overlap on the different maintenance strategies. Like there is overlap between major minor rehabilitation and the preventive maintenance.
Yes.
So, and there is overlap between major rehabilitation and the reconstruction.
Yes.
So what does that overlap suggest?
The overlap is that what it means is that number one, there is no single size fit all design. Even though you do a routine maintenance or resurfacing, the pavement will eventually fail. So the question is that whether to do a preventive maintenance in 2020, resurfacing in 2022, or a major rehabilitation in 2025. That's the question. So when you do the preventive maintenance in 2020, the payment will may extend to 2025 or 2026. There's an overlap. That's how the overlap comes into picture. Even though you do a resurfacing in 2022, at 2025, the payment will still not have reached a stage of very bad, do nothing strategy. The life will be better. So there is an overlap between both.
So further in this, I would like to know how judiciously we can decide to go for whether it's go for preventive or go for minor or means any other.
That's what you should link it to the structural condition of the pavement. What I would suggest is that you should carry out a deflection studies. Once you see the cracks, you can take a core and check whether it is a top-down cracking or a bottom-up cracking. Secondly, you carry out a deflection study, either a Benkelman beam deflection studies or a falling weight deflectometer studies. Find out the structural adequacy. If the pavement is structurally adequate and functionally deficient, and if it's a national highway, go for a bituminous concrete. If it's a state highway, you can go in for other thin surfacing that you can think of. When it is a case of reflection becomes more, go for a thicker overlay. So that you have to decide based on the structural condition.
Yes, sir. So just suppose after that, if we will able to get that from just suppose 100-kilometer stretch, only 30 kilometer is having, or what is the amount where we can go for the higher kind of maintenance, and means just suppose there is only 30 kilometer which is having major distresses and rest of things have minor. So whether we would go for section wise or we would go same for the whole stretch.
And that's a good question. It's quite possible. For example, there's a highway length of 100 kilometers.
Yes, sir.
In this 100 kilometers, there can be a major junction. With the result, the traffic on one side of the junction may be lesser, the other side of the junction can be more.
Yes.
It's quite possible that 70 kilometers is highly trafficked and highly distressed, and this 30 kilometers can be relatively less distressed. So what we should do is that you should do a road inventory survey. So we are now introducing that in the IRC 82. It has got a distress survey form. Using the survey distress form, you carry out the distress survey kilometer wise for all the 100 kilometers. Then go to the AICTE. It has got a cumulative difference approach, CDA approach. Group them into homogeneous sections based on soil type, based on traffic, based on roughness, based on pavement condition index. So if this 30 kilometer falls one category, suggest a treatment for these 30 kilometers. Even the 70 also, you can group into one or two subsections depending upon the soil type, traffic, and distresses, and you can go in for one or two type of maintenance treatments. All the 100 kilometers need not have the same treatment.
Yes, sir. Yes, sir. Thank you. Thanks a lot. It's always a pleasure to listen to you. Thank you.
Any other question from anyone?
It seems I'm not able to see any raising hands.
Okay.
Sir, I have one doubt or information. Always I have come across with SDBC as a victim.
Yeah.
But many of the roads which are low volume roads with less than 10 MSA already we have constructed.
Yeah.
If there is any distress or any failure, is it only because of the semi-dense nature of the SDBC, or is there any more failures that are reported from the SDBC surface because of the SDBC surface?
See, I do not know what is the meaning of this semi-dense. Either it should be dense or open. I don't know what is going to be semi-dense.
Yeah.
They have named it as a semi-dense. It doesn't matter.
Yeah.
But what the performance, what they have found is that is not that. For example, Either provide a 40 millimeter SDBC or a 40 millimeter BC. If you look at the life of the 40 millimeter BC, that is much better than 40 millimeter SDBC. It goes with the gradation, it goes with the binder content. So that's why I say if the traffic volume is low, like village roads, rural roads, PMJSA roads, MDRs, ODRs, I still feel that we can go in for SDBC. Only when the traffic volume becomes more, we should go in for a BC line.
Oh, thank you, sir. I mean, we should not be by the semi-dense word.
Yeah, that is what is only creating confusion.
Yes. Yes.
That's why now we are thinking of bringing out another gradation for the BC with a 9.5 millimeter down, which can be used even for urban roads where the traffic volume is less in lieu of the previous carpet and the mixed seal surfacing. We need a mixed design. Only then we will ensure a good density of compaction, good workability, adequate voids, and then performance will be better. So all these open graded mixers should be removed from specifications, BM, PMC, MSS, then the life will be easy and simple.
Thank you, sir. There is one more attendee, Dr. Hari Krishna and Dr. Vishnu. Dr. Hari Krishna, please.
Good morning, sir.
Morning, tell me.
Good morning, sir. Sir, wonderful, insightful lecture, sir. Sir, one small query from my side. Sir, as far as overlay treatment is concerned, it is considered to be corrective maintenance or preventive maintenance, sir? Overlay treatment?
If that's what I repeat again. You may carry out a deflection study.
Sir,
I would say that if the deflection pavement is good structural condition, then you can ask me what is good. I would say that based on my experience, if the deflection, Begelman beam deflection, is less than 0.75 millimeter, assuming that the roughness of the pavement is around 4,000 millimeters per kilometer.
Sir.
So the deflection is not very high. Roughness is 4,000. A 40 or 50 millimeter bituminous concrete will be adequate.
Okay.
When the deflection goes beyond 1 millimeter, 1.25 millimeter, and the roughness is around 4,000, then I would go in for a corrective maintenance.
Sir, okay.
Yeah.
Okay, sir. Thank you. Thank you, sir. Thank you very much.
Sir, I have sir.
Yeah.
Sir, in a hilly areas, the roads are damaged due to sir weather conditions or any environmental conditions. What is your suggestion to better roads to can make a better material?
So in the case of that's what I do not know what is the type of mix that they have used. Generally, what I have seen good roads as well as bad roads in hilly region. In hilly region, bituminous concrete, which is generally a dense graded mix, should work. So I don't think that they should go in for SMA as in the first step. If the BC fails, we can go in for that, but never ever use a premise carpet, mixed seal surfacing on a gut roads, because there are issues of drainage. Issue is a major issue. Permeability, unless you provide a dense graded mix, the permeability problem will not be sorted out. And more importantly, construction quality. Ensure that the right binder content. You can add maybe that 2% lime, as I was mentioning, to enhance the moisture resistance. And you can ensure that the density of a compaction is at least not less than 93% by the maximum dry density, theoretical maximum density. And that will ensure the hill roads will last longer.
Yeah, thank you, sir. Thank you.
Yeah.
Thank you, sir.
Hello, sir.
Yeah.
Sir, you have actually presented the BC3 gradation in one of your IRC paper, along with Kandal, sir. Yeah. So, can we actually recommend it for thin overlays?
Yes.
Can I actually cite that IRC paper, and can I actually ask contractors to go for it, or maybe some test sections? Can we ask?
I would recommend yes. I think someone has to do the study.
Okay, sir.
I see any layer thickness less than 40. Say 30, 25. I strongly believe that 9.5 mm down gradation should be adopted.
Okay,
so if somebody can do a trial section and then come out with the performance, it will enable us to bring in the ARC code of practice easily.
So possibly we can actually refer to that IRC code, IRC paper, and then.
And yes, somebody has to be willing to construct a test track.
Okay, sir. We will take care of it, sir.
Yes,
okay.
Then fine, no issues. Definitely. You can ask us also technically. We can also able to support you that it should be adopted.
Thank you, sir. Thank you, sir.
Yeah. Any other questions? It looks like that's all the questions, Suresha.
Sir, yes, sir.
Yeah.
Now we have crossed 11:33.
Yeah.
Sir, thank you for your wonderful session.
Yeah.
We have right now more than 80 attendees are involved in this. I have conducted a couple of quizzes online.
Okay.
That is, I had two questions. One is in the design of payment, do we need to consider top-down tracking or not?
Yeah.
But it has been put it in another way.
Yeah.
The design we do not consider top-down tracking. How many of them said yes or no? And another one is it is suggested that mixed sill surfacing should be directly laid over waterborne macadam. Correct or incorrect?
Yeah.
So nearly 25 have responded.
Yeah.
So I have not announced the results.
Okay.
But I think all the participants are actively involved. It shows their presence in the session, sir.
Okay.
So
good.
thank you very much, sir. With this, we'll end the session.
Okay.
Yes, sir.
Okay. Thank you for inviting me again, sharing my thoughts with the participants.
Really value addition first, sir. Thank you, sir.
Thank you very much.
Yes, sir.
Thank you.
So you can leave. I have few instructions to the participants.
Yeah.
Yes.
Thank you very much. Yeah.
Thank you.
Thank you.
Dear participants, I have already sent a link. I hope that you have got the link to your email. We'll join sharply at 12 or even before. We have the next speaker on the next speaker, Dr. N.C. Paul. He is a chief engineer from Orissa PWD. He will be sharing knowledge on Orissa road asset management and also draft IRC guideline on road asset management. Please do join. At this moment, I will close the session, this particular session, and we'll join with the new link and we'll start the session sharp at 12. Thank you all.